questions from worksheet 1? Number 1. Good. We need to do one of them just to get our brain back going with this parametric thing. Because this is very new, right? This is x is defined as a function of t and y as defined as a function of t. As opposed to the old way was y is a function of x, and we graph that. The new way is x is a function of t, y is a function of t. And so we end up with a table of values that has 3 columns in it. Now, we only use 2 to graph, but we need that third column as our t column to figure out what to plug in to x and y. All right, so number 1, x of t is the square root of t. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And I think we figured out that rather than going row by row, it's probably easier to go column by column. So get all the x's. That way your brain is constantly taking square root. Then do all the y's. 3 minus t. So 3 minus 0, 3 minus 1, 3 minus 4, and 3 minus 9. Graph the curve. Well, this is an xy graph, so we will use the x and y column. So when it comes to the graph, we no longer need the t column. We'll just use the x and y column. So 0, 3, 1, 2, 2, negative 1, and 3, negative 6.
It could be.
Now that graph is not quite finished because what do we need? Arrows. Because this has some progression to it. We started at t equals 0. Some people would even label it. You don't need to, but if it helps. Start at t equals 0 and went that way. And yeah, it's not a parabola. There isn't another side. Yeah, I wish it was a little more clear on how much it wanted us to graph, but it doesn't specify, so we can stop there and be okay. So you can just plot what's there. Part C, find the rectangular equation by eliminating the parameter. So that means solve for t. So x is the square root of t. So if we square both sides, x squared equals t. Y equals 3 minus t. So x squared goes in for t, and y equals 3 minus x squared. And on some of these, the graph may be simple enough for you to either sketch it or at least picture it in your head to see that it matches. Like 3 minus x squared, that would begin at up 3 and then be an upside down parabola, and that matches what we had. So if you know what that graph looks like, you can kind of check to see that it's right. Sometimes you won't be able to do that though. So all right, all of the questions are kind of the same. Table of values, do the graph, and then eliminate t. Number 3. Yeah, that's the one with the sines and cosines. That one's got a trick to it. Plus all the unit circle stuff. Okay, I'm going to go quick on the unit circle, assuming that if you don't know it, you can go back and figure it out. You don't have to write the equation right there on the table of values, but I think it's helpful. It keeps it organized, easier to find. So 2 times cosine of 0 is 2. Cosine of pi over 6 is root 3 over 2. So that would be root 3, which they conveniently tell me. I'm just going to round to 1 decimal because when I'm plotting on a graph, like I can't tell on the graph the difference between 1.7 and 1.732. Like, come on. So 1 decimal is fine when it comes to graphing. Well, I'm not telling you they don't matter. I'm telling you when it comes to a graph, they don't matter. Like, you can't tell the difference. 1.4. Cosine pi over 3 is 1/2, so that's a nice one. Cosine pi over 2 is 0. Cosine 2 pi over 3 would be negative 1/2. Cosine pi over 6 is negative root 3 over 2. So negative root 3, which is negative 1.7. Cosine of pi is negative 1. Cosine 5 pi over 4, negative root 2 over 2. Cosine 3 pi over 2 would be 0. Cosine 7 pi over 4 is root 2 over 2. Uh-oh, did I mess one up? Yep. I'm going to go too fast. I bet I would have caught that on the picture because that graph would have looked really funny with that point. So, some built-in check. When you do multiple things in a problem, sometimes it checks itself. Okay, all of that for the x-coordinates. Now I got to do 10 more problems for the y-coordinates.
Whenever we have the unit circles, are you going to have all of these things, or is it just going to be like the normal like 5 or 7 max? Like, are we going to have to do all of those?
I mean, you got to fill out the table.
I mean, yeah. But
and
like,
you see that toward the end we start skipping more. Like, it takes all the way down to here to get halfway, and then we start skipping around a little bit because we want you to do enough points so that your picture's accurate.
Okay.
Right? If you only did 5 points, unless you've done a bunch of them, you wouldn't know what it looked like. This is going a little faster because all these values are the same values, just in different places. Pi over 3. Wait, is that right? 5 pi over 6 would be positive 1. Let me slow down a little bit here. Sine of pi is 0. Sine of 5 pi over 4, negative root 2 over 2. Sine of 3 pi over 2 is negative 1. I think the pictures help me go faster. Sine of 7 pi over 4 is negative root 2 over 2. And sine of 2 pi is 0. Now let's put all those points on the picture and see what we got. So 2, 0, 1.7, comma 1, 1.4, comma 1.4, 1, comma 1.7, 0, 2. Negative 1, 1.7, negative 1.71, negative 2, 0, negative 1.4, negative 1.4, 0, negative 2, 1.4, negative 1.4, and 2, 0. So now you can see graphically, like these first quadrant we graphed all the points possible. Second quadrant, we graphed a few less. Third and fourth, we graphed even less. But the hope being, hey, if you did that many in the first quadrant, you might get a better picture of what's going on. arrows. That sure looks like a circle. Because the arrows are going that way because we started, this is where it would have been good to label t equals 0, t equals pi over 2, t equals pi, and so on. So we rotated around that way. Find the rectangular equation by eliminating the parameter. Well, this is the different one. Normally we would try to solve for t, which would involve an inverse cosine of x over 2, which would be really ugly when we got to the other side. So what's the trick for this? What do we know about sine and cosine?
The squared thing equals 1.
The squared thing equals 1. Sine squared plus cosine squared is 1, or cosine squared plus sine squared equals 1. So x over 2 squared plus y over 2 squared equals 1. Which would be okay, a good enough place to stop. But if we really want to make it look like a circle, x squared plus y squared equals 4. That's another one where we know what that shape is. Circle, radius 2. And that matches the graph that we have. So, not too bad yesterday. Completely new stuff. But a 3-column table. Graph it like normal, except with the arrows. And then solve for x and y.